There's always one person. Last week it was you.
I
This week
was
it's you.
about to say.
There's no need for those shades.
Oh, there's no need.
There's no need for. I come in peace today, so. Also
I am at peace, always now.
Yes, sir. That's what old teachers say.
Okay, number 44. I'm sure you had an idea how it works, but you just got the wrong answer for making an unnecessary mistake. And you made some other issue there. So of course you can use the formula. It's for 5 terms. So this is first term, second term, third term. And I just add all of them, that gave me 62m. But of course you can use the formula, S5. And then you fill in what is the A value. Here's the A value. A is 2m, and to go to that side we have to multiply it by 2, and then you will get the same result. You just made a mistake there with it. I think you had it at the bottom right. Yeah, this is not 2 power 5. That is just too much.
Oh, okay.
But you had the right idea. But you'll get the same answer. Jesse, the memo is there, so you don't have to copy everything in Hardy. This is just to explain a little bit of what's going on. This 46.2, I've done it in 2 parts. So the first part is that first sigma notation, that's 7p minus 22. So I've developed a pattern. From that I learned that I have an AS, and also what is the A value and the D value, and S18 was then 801. Then the second part of that second sigma notation is a geometric pattern. Develop that, and this is what I got from that. Then here I use the formula to get something in terms of n. So I just work this out, multiply the 72 in, and this is what I got in the end. Now we have to subtract these two from each other and get that result of 423. So on the memo, this one I had as 432 over 8. So just check that you correct that. So this is correct and this is correct, but I just had a mistype there. You see, it's I said once 432 over 8. It should be 423, like this part in black. Did you get it there, Andrea? Jesse, do you see it? So over here, that must. Oh, I've changed yours.
It's 46.
Yes.
1, 2, 4.
So it's just a mistype. So this is obviously wrong. But the rest is fine. And then I worked it out from there, and from that I got into B6. Now you got the right answer. You had part of this correct. Something here went, something went wrong here. Not 100% sure. I think even this one you had wrong, but then you add, I think you added to that side instead of subtracting. So just go and check that again. Then 49, I think you sent me, you asked me for the memo on this. We have to see this. You wrote a long novel there for me. Like how many lines? 5 lines.
2 lines, so it's not 5, it's 4.
Oh, but it's something like, there's no pattern and I don't see this, and...
I saw the pattern, it was just to get the formula.
Okay, so this is what we need to see here, is that you have 2 different patterns. The one is just 3, 3, 3, 3. If you try to get the difference there is 1, the difference there is 4. The difference here is minus 4. You're going to realize that something is not going to work. And then check for type of pattern. So there clearly we have the 3s as one pattern, and then this in blue, the other one. So I've done the blue first, and that was a number of 121 is the last term. And from that I could work out how many terms we have, because I need that. So that will give us 40 terms. So the S of 40 is going to be using the sum formula. And then I use the same for the yellow one, but that is just 3 times 40. 3 will be there 40 times, so that is 120. But you can see if you saw the pattern in the beginning, this is really nothing to it. But it's confusing because you're so used to going, okay, but this is 1, that's minus 1, that's 4,
So
that's
they can
minus.
put 2 patterns in one.
Yes, so you have to see it like that. Okay, so next time that you get something that looks odd, just check if it's not maybe two patterns.
I saw
It's-
that, sir, and then I thought I didn't explain.
Yeah, you did explain it to me. I didn't understand your explanation, but at least you tried. But that's fine. It's also possible that you have an AS combined with a GS. I'm going to show you an example just now about that. So and then the final answer is 2620. So let's say something like this. Two, four, six, eight, 10. That is clearly an AS. We're adding 2 all the time. You see, there's another one there. So now there's naught, then 2, then naught, then 2, then 2, then naught, then 8. You see, there's not something, and then you need to realize, okay, let's check every second one. So if you look at the green one, that is 2 plus 2 plus 6 plus 2, adds 2, adds 2. This one is 2 times 2 times 2 times 2. So when you see something that doesn't make sense, or there's not, you can't work out whether it's an AS or GS, maybe it's just 2 that is combined. Or even something like this, where that forms a fraction, that forms a fraction, that forms a fraction. Even something that looks like this. So now if this can be 1 plus 1 plus 3/4 plus a half. But they will not give it to you like this and expect you to see that. But if this is typed like this, just check that the top part there is an AS, the bottom part is a GS. So if you get your TN, you will have the AS on top of the fraction, the numerator, and the denominator will be the GS.
We did something like that, I think.
Okay. Then the last one, you had it right, Andrea, except you used 9 over here instead of T9. So you made this 9. You see that? That was not what you had to do there. You had to calculate the 9th term. So you had everything right, you just messed this up here. So I would say a question like this is maybe 3 marks, 4 marks. So you'll get like 2 out of 4. At least you will get something, but that's not what you want, more than just something. And then I made notes, or I have notes of the inverses and functions. In school, I'm sure you must be finished with this by now. Are you? Or if you're not finished, you should be close to finished.
Yeah.
So this is just to wrap up whatever. There are 8 pages of memory, just one for brother.
Thank you. You know what's so nice? Tomorrow we have from 7 till 9 maths, and then Thursday from 7 till 9.
Yeah, you leave us a lead.
Yeah,
That's fantastic.
that is me.
So I'm just going to say the same things that was said in school, just to make sure that you have this. This is not difficult work, and most of this is really familiar to you. That means that you cannot lose 1 mark with this. So I'm not going to do all the examples or all the exercises there. I'm going to start later in this page. Of course, the first view is just explaining to you how it works and that. So you can go and work through that yourself. I'm not going to waste more time with this. Next week we'll... Have you started with compound angles yet? Trigonometry? You started
now
with...
statistics we done this Saturday, and now we're doing probability.
You do probability. Okay. But next week we'll do with
I will
trigonometry.
continue
No,
with the...
Yes. You can just, if there's something there that is an issue, you can just sort it out with me.
I have a very nice summaries of all the things we do. It is that science clinic for maths, so I'll just maybe send it. If
Sure.
you want. It helps a lot. I don't know.
Yeah, okay. So, just about what is a function and what is not a function. This is, if you had 1 too many, you will not function. That's an easy way to remember if something is a function or not a function. If you have 1 too many drinks, you will not function. That's where
We
it's
have
from.
that good woman. We got that.
Yeah. And then if you add many too many, you will definitely not function. So that means that a 1 to 1 is a function and a many to 1 is a function. So one to many and many to many, not going to work. It's not a function. And these, all three here, not functions. This one is a one to many, and that one is a many to many, and so on. Not important really. What you need to know is that a vertical line cuts this more than once, then we know it's not a function. Okay, that's an easy one. So if they ask you if something is a function, and you can't remember all of this, just say that the vertical line cuts the graph more than once, then it's a function. Okay, that is all that I have to say about something being a function or not a function. We have actually done this with you in grade 10 already, but at that stage you were not paying attention really. Now you're not paying attention as much, but at least now you know there's something that's going to happen sooner rather than later, and there will be some reckoning. And that is... Okay, so you will only get three types of functions. One is a linear, quadratic or the parabola, and the other one is an exponential function. So again, this is not new. I'm just going to refresh your memory with this quickly. And there's a certain way that you have to make sure that you can do that, you write this properly. So this is, you will see I explain it on those notes as well, exactly what I'm doing here, not the specific problem, but exactly what I'm doing here, is that I write this as y equals to x plus 3. So that is the f function. And then the inverse is to that power of minus 1. Don't say power of minus 1, it's really inverse. I know you're not doing an oral test, but still. So this is x equals to y, and really the x and the y just swap places. That's all it is. And then that comes across to this side, and we make y the subject. So your inverse will be y equals to x minus 3. And when you draw these, just as simple. Just draw the first one and then just swap the values. So if I have to draw this graph and make x 0, I'll get y equals to 3, and if I make y 0, x is equal to minus 3. So I would say 3 here. What was the other one? Also 3.
Shouldn't that be negative 3 then?
Okay, if x is 0, y is 3, and if y is 0, x is minus 3.
Yeah.
I'm not dealing with this one. I'm just doing the one in red.
Yeah, but I mean that 3 shouldn't be negative 3.
Which one?
The one you just wrote.
Yeah. Oh yeah, you mean like this?
Yeah.
Yeah, thanks. And to draw the, and also always with this, I don't know if they've emphasized this enough, you always have to have that line there. First of all, it helps you to see if your graph is drawn correctly, and it's just the right thing to do. So, so again, y equals to x.
Why is that there? What is that?
Oh, that is the line, that is the mirror, that is the line of reflection. So this graph, this is the original graph. So this is the graph of, okay, let me just change this to pen.
No, that's the fx. Oh,
This is the f graph,
The original.
the original. So it has just the f. The inverse will then be, if the x value is 3, the y value is 3, the x value is then 3. If the x value is minus 3, the y value is minus 3. So this graph will look like, and this will be the inverse. Okay, so drawing the straight line then. And now you can clearly see that this is the line of reflection or the mirror, to make sure that you have that. So draw the original one and then just swap the values around. If you really want to go do this, you can go with having this as minus 0.3, and this is then 3 naught. Swap the x and the y. Here we have minus 3 naught, and over here we'll have minus 3. Again, the x and y just swap places. Okay, straight line. So this is quite a popular one, well actually all three of them. If I want to change this one into, I'll go with y again, minus x squared. So I'm writing the original graph with a g in front, and then I go with g minus 1, which is the inverse. and that would be x equals to minus y squared. So x becomes y, y becomes x. Straight swap. So if I do all of this now, I'll have y squared equals to minus x. I've moved this across, it became positive, that across to that side became negative. Getting rid of the squared here, we'll have y plus minus, always plus minus, because this graph has two parts. Minus x, the square root of that. So is this not a problem?
I would just go with the square root from the next step.
Say again?
I would just get rid of the square root, not go square the other side. The previous step, I would just skip that one.
Oh, go from there to there.
Mm.
Yeah, that's fine. My issue is this. Is that a problem, yes or no?
No, because if you
Okay,
put
yes,
the-
why is it a problem?
Because of the square. If
Square
it's a
root.
square, oh sorry, the root then
Yeah.
it can't be negative. Oh,
Okay.
it's cube.
Oh, I thought about like negative times. Oh, yeah, no, wait, my.
You
Yeah,
can't
it's
multiply
gonna
the
be-
negative in.
Yeah, it's going to be a problem. So then can't you put it above? Oh, no, you can't.
So why is it a problem? Why is it not a problem?
It is a problem.
No, it's not.
You can fix it, but it is a problem right there.
No, it's not.
So it's not-
But you can fix it. This is the issue. If the pen doesn't write it is the issue. This is the issue. Because the square root of a negative number is an imaginary number or complex number. This is not a square root of a negative number. This is the square root of a negative unknown.
Oh, so it can be.
So the x values that will apply here will only be the negative x values, like negative 1 or negative 2, because negative times negative will make that a positive. So although this looks funny, this is not the same as that.
So is it a problem?
No, it's not.
Now, how would you fix it if it was a negative 2, let's say?
No, well, you can't. Well, then you just have a straight line.
Okay.
So no,
then
no.
You will know then it always.
So if you have the graph y equals to minus 2,
Mm.
and you want to do the inverse, there's no inverse to this graph,
Okay.
because there's no x that I can swap with the y. So this is not a problem, because the negative has to do with the unknown. So as long as the unknown is negative, the negative on the outside makes it a positive. Okay?
So it will always be, hopefully, negative. Like,
No,
what if
it can be
the
positive.
x was positive?
Then it's fine, then only the positive x's will work.
Okay.
I will show you on the graph just now. That will make more sense once you see the graph of this. Okay, so this is clearly a parabola, but it's a sad face. So having to draw this, we can go with, let me just see, 1, 2, 3. I'm just going to go with,
Then you can put in any value if you want to draw it.
say again?
For the previous equation, you can put any value in order to draw it.
Yes.
Okay.
But I normally use 1 and minus 1 because that's easy. I can go with minus 2 as well, and that will just go through
But
4.
yeah,
1, 2,
yeah.
3, 4. So minus 2 squared will give us negative 4. And the same on this side. And naught, naught. So there is the graph. Okay, this is not going to. Well, I would say that is not too shabby.
Mhm.
Not too shabby at all, I guess. I'm going to go with values here. That is 1, minus 1. And on this side, minus 1, minus 1. So if I go back to my graph and I fill in minus 1 there, it's minus 1 squared is 1, times the minus on the outside will give me the minus 1, minus 1. And the same here with minus 2, minus 4, and 2, minus 4.
Just so that dotted lines that you always draw it through the 0.
Yeah.
Or
Yes.
X long.
It's y equals to x now. So if x is 0, y is 0. Or if x is 2, y is 2.
With the exponential one, it's also where you have to have a word contact.
Yeah,
So-
we'll get, yeah, I'm going to do an example of that shortly. Okay, now check this. Where is the inverse? This is G. Where is the inverse of G? Oh, that should not be there. So we just swap the values around. Naught will still be a value. Let me just do this in a different color.
-1.
So we will have -1, this value is still here. This one is 1 minus 1 will now be -1, 1. This was -2 minus 4 will now be -2, -4, -2, so somewhere here,
So it's just
and that one there. Okay, that one was a bit skewed.
It started
Try that again.
good.
Yeah, but it's not how you start, it's how you finish now.
Right.
Now what do you notice about this blue graph? About the inverse. Can you see it can't go to the positive where x is positive? X can only be negative. And this is why this is always true. The plus and minus in front here has to do with the fact that the graph lies below the line, that's the negative, or above the line, that's the positive.
So if that x was a positive, it would be this side.
Yes. So if we had, let's say, y equals to x squared, the graph will be there and the inverse will be there. So then x can only be positive.
Perfect.
So this that we have here, if you look at this now, you can see that is why the graph lies on this side. X can only be negative. Do you see?
You got it?
Andrea? Good. So I don't work out how to draw the inverse. I just check the points that I have of the original graph, and then drawing the inverse is just swapping x and y around. That's all.
And if you really struggle, you can use your calculator.
Yes, and then you can get all the dots there.
So does that apply to all the graphs? Or
Yes.
just swap them in?
So it doesn't matter what, but you only do 3. There's no sense in asking you a hyperbola, because hyperbola, if the hyperbola is drawn here, and this is the line of reflection, that part ends here, that part, it looks the same. That's why hyperbolas never ask. Or even if it's there, it just does that and then it does this. So hyperbola is never there. So it's straight line, and parabola, and then this one, the exponential graph. Okay, so going with the exponential graph, h is equal to y equals to 2 to the power of x. Its inverse is x equals to 2 to the power of y. Now here we need to use the log laws, or a short way is just that the base is always the base. That means that the base in the exponential form, this base, is always the base. That's how I remember that. There is a way in which you can use the laws. I can show you that. That's another way to get it. Or maybe I should just do that.
So is it logs?
That's log. What does it look like? Leg.
It looks like a cheese, like a cursive.
Or like a C, like a wave. That's about to kiss.
Yeah.
But Jesse, since I'm...
Actually, it looks like a music note.
there we go. Is math and music not related?
No.
I don't think so. Because I've known a few music people in my life, serious music people, and they're all crazy.
Yeah, that's true.
They think I'm crazy as well, but I
I
know.
have to say that is a
That's
very
very
true
true.
statement.
Yeah.
Like,
It's
especially
profound.
the teachers,
Yeah.
all of them.
Just look at what we had at that
Teachers.
school and what you have there now.
Yeah.
I don't have to go into that though. Those are just not
I also know
crazy.
the previous choir teacher.
Okay, happy with this? I will just quickly show you how to get to that. So I'm going to start with this one, x equals to 2 to the power of y. So if I log both sides, like that, then logs allow you to bring the power to the front. So this becomes y log 2, and this is log x. Now at the moment this seems that it doesn't have any base. But that just means the base is 10, because we're working with the decimal system. So there's a 10 here that we don't write. You will see even on your calculator. This log button here is the one that has there's the base and there's the other number. Mine doesn't even, and this log here, the one that, let me just remove, that doesn't have a 10 at the base. Because it's not written there, because we're just dealing with decimal numbers. And then if I divide by multiply that on this side, then I will have log x over log 2.
Can you quickly go up, maybe? I just want to quickly write this, please. Thank you.
So I'm using really two log laws. The first law is, well, I just log both sides. What I do on the left-hand side, I do on the right-hand side. Then that power is transferred to the front. That is one of the log laws. And then to make y the subject, I divide by log 2 on both sides. And then this, if I have log x over log 2 to any base, we can change that to log x base 2 equals to y, and that is where this is from. But the base in the exponential equation is the base in the log equation. And you also know that the log of a negative number doesn't exist. The log of naught does not exist.
Also, the one where, like, let's say it was y equals to log x minus 1, then you take the entire
Yes. But then it must be the bracket.
and brackets, yeah.
Okay, so that is just to give you some of that. So drawing this one first, I use 3 values to draw that, just to give me an idea of what the graph is going to look like. So I make x1, I make x negative 1. So if x is negative 1, to the power of negative 1 will give me a half. 2 to the power of 1, 2 to the power of naught is 1, and 2 to the power of 1 is 2. So here I'll have 1, 2. Now this graph cannot touch the x-axis. So that is what the exponential graph looks like. I always use these 3 values, and if I can't get a proper idea of what the graph will look like, put it into your calculator, go to table, get more values. Okay. We know that the x-axis here is an asymptote because there's no power that can make a base 0. And then to go with the inverse here is really as straightforward as this. This is naught 1, so we'll go through 1 there. And you can see the graph, it must look like this, because this is the line of reflection. And here we have, 2, 1, and here we have 1 naught, and then this one is a half minus 1, so somewhere here. And now this green graph, and always indicate on your graph which is which. Sometimes the log graph is the original and the exponential graph is the inverse. Now the exponential is normally the original graph and the other one the inverse. Easy to see this now with this line. Can you see that line tells you immediately whether your graph is drawn correctly or not? I just want to add another one here to show you what I mean by that. That's not the idea. Let's say you have the, how to do it like, I just like an hyperbola, that will not work. Okay, so this is exponential graph, it passes through 1 day. So if you have to find the equation of the inverse, or the graph of the inverse, there's my line y equals to x again. This line is not touching the x-axis, so that means that the inverse will not touch the y-axis, and it will look something like, let me just retrace my, it needs to pass through this point, where this is then the inverse, and this is the original one. See, this one is easy to see because it looks like this. And if the graph is something like this, you just have to keep this in mind. I'm swapping those 2 values. At this point, where it passes through that axis of symmetry, must be the point where both of them pass.
So is that where the y and the x actually swaps? Like, yeah, the one is on the y value.
Yes.
And the
So this is naught 1 and this is 1 naught.
Yeah.
x and y swap places. Over here, they don't swap places. This is, well, that point must be square root 2. I know you know that, you just know that. You know that this is square root 2, square root 2. Why is the square root 2 square root 2?
Square root 2, square root
Is it square root 2 square root 2?
2. I don't think it can be because it's...
Square root 2 is larger than 1, so it can't be. Half of square root 2.
Yeah, then...
Doesn't matter. You have the idea. But that will be the same point, obviously. Then x and y will be the same because it's on the line y equals to x. And then another thing, just to go back to the straight line graph. I know you've done all of this, hopefully, in class already. Have you not? What is the domain and range of the original graph here?
The domain is the x value, so then it would be for which one? Oh,
The original graph.
negatives 3 and 3.
No.
The domain is negative 3
No.
and range is 3.
So what about this value? That value? that value.
It's like the infinity.
So it means all the values,
Yeah.
is it not? So the domain for this graph will be all the values, because the graph continues to that side, continues to this side. What about the range of this graph?
Also.
The same. So for this it will be the same as well. So the question, if they ask you for the domain, you will just say x an element of R, or you can say x an element of minus infinity up to infinity.
Yeah.
Whichever way you prefer to write this. Parabola. What will be the domain of the original graph?
The original. Oh, so also the same.
All values.
All values.
So the domain is all values, x an element of R.
Yeah.
What will be the range here for the red one?
Also
No.
not the range.
And be restricted by the turning point.
We are restricted by the turning point now. So that means that our range is y, y smaller and equal to naught, y an element of R. The domain is all the values, so most probably not ask you that. But what about the blue one now? Now the domain is what the range was in this one, and the range will be what the domain was. Now the range doesn't have any restriction. But the range has a restriction. X must be smaller than naught, x an element of R, as we see from this. You understand that one, eh? So is the original graph a function? Is G a function?
Yes.
Does a straight line cut it? Can a straight line, vertical line cut it more than once? No, it can't. It cuts it once.
So
Is the blue one a function?
no.
No, it's not. Look, a straight line will cut it twice. So how can I ensure that this one is a function? We lose part of this graph, and then it's lost in that one as well. So if they ask you to restrict the original graph so that the inverse becomes a function, then you have to do something like this. I don't know if this will work. Let me just see. I can use this. So if I just look at that part of the graph, then the inverse of that part is this part.
Yes.
And you see that this second one that I drew here, that line cuts it only once. We're ignoring that now. So that means that I'm restricting the original graph by looking only at the positive values. Or I can restrict it and say, well, this one here goes with that one there.
How do you write that?
X smaller than naught, smaller than equal to naught, or x larger than equal to naught. So if the question is, there are questions like that in that paper. The question would be, how would you restrict the original graph so that the inverse is a function? Then your answer is really as simple as writing x less than equal to naught, x more than equal to naught. So naught is included there, but it must be either positive or negative. And what happens when we do that is we lose one of the legs or one of the arms. Well, I don't know what you call that.
And so it's always x.
It's always x because you're restricting the original one. Let's say they ask you to restrict the inverse. What will it then be? Then it will be y. But that is a rare question. It's normally restrict the original one. How would you restrict the original one? So this is all you need to remember. You don't have to have anything more than that. X smaller than equal to 0, x larger than equal to 0. And this is normally for 2 marks. But you have to write down both. Okay, I think that is all we need to know. Okay, back to this one, just to get domain and range here. Okay, let's look at the red one first.
Yeah.
This graph continues there, continues here. So that means that the domain for the original graph is will be all values, x an element of R. What about the range?
Also,
No,
no.
can't go below here.
Oh, so you would say
So y
Yes.
must be larger than 0. Not equal to, because it can't touch the line. JC, you with me? No, you're not. So there's the range, x an element of R. Because all values apply. This graph continues there, continues, so we have no restriction on x. But we have a restriction on y, it can't go past the asymptote. So that's why y is bigger than 0. If I go to the inverse now, this will just swap around. So y should be an element of R, and x should be bigger than 0. Is that the case? Check. Y has no restriction now, but x must be bigger than 0. You see they just swap around.
So that's the asymptote.
No, this is the,
Also that green line.
this line.
No, so
you mean the dotted one.
No, that's not the asymptote.
oh.
Asymptote means the graph can't touch it.
Yeah, the graph.
In this case it doesn't, but that is not, this is just the line y equals to x. Here's the asymptote.
If you look at the other one, you see it even.
Now this example that I've done here.
Yeah, it passes, so it touches.
So that is not an asymptote. It is, this kind of line can only be an asymptote. No, we don't have a line that runs like that. It's always a line of, yes. Asymptotes, yes. So this is the asymptote, the x-axis,
Mm.
for the original graph. Then the y-axis for the inverse, because it can't touch it. Does it make sense? But I want you to see that these two really just swap places. X an element of R, y an element of R. Y bigger than 0, x bigger than 0. Are they both functions? Does a vertical line cuts it? Does a vertical line cut it more than once?
Both functions.
Both functions. The only one that you do that is not a function is this one.
Okay.
It's only with the parabola that they will ask you to restrict the domain of the original graph to make the inverse a function. This is really not a difficult chapter. That is all the work you need to know about this. Those are the only questions I can really ask you. Then I have, are there any other questions here? Or something that's not clear? And you know, a question like this is maybe worth 1 mark or 2 marks. But you know, everything counts in the end.
Yeah.
And I like to ask this one,
Log.
because logs is something that is new to you. But I know we used to do logs as a whole topic, but now it's just a tool that we use for this, and we use it in financial maths as well. Just as a tool, like we use it here. Okay, then I have exercise 5. That is on your page. So you can see there are other exercises. If you want to do them, you're more than welcome. Exercise 1 is just the revision of grade 10 work. And then I have an explanation of each function with the solution on pages 2 and 3. And then on page 4, also drawing the inverse. You can see there's a whole step of which you go through. Then exercise 4 is where you can draw a few straight lines and their inverses. I'm at exercise 5. So you can draw it on that page there. They ask you, or I asked you there, sketch the graph of the inverse of each of the following. Just draw it with a pencil there on your page. Don't go and redraw it, it's going to waste we're running out of time. You can do it later. Just fill it in on the sketch. So how will we draw the inverse of this graph?
That one.
Well, that is the first one there on your page, is it not?
Yes, it is.
Or does mine look different to yours?
No, then you just weigh one.
This is really like the previous example.
Yeah,
I've
you
done.
just put it by negative one.
No, not negative.
What is your x?
Yeah,
Oh, yeah.
now we have to go there.
Oh, then it goes. Yeah.
And then it goes here. Something like that. So Andrea, I can see you frowning. Not good for the old age lines that will form here eventually. So what do we have here? We have mod 1. So this is 1 mod, an easy swap. The red graph, the original one, cannot touch the x-axis. Therefore, this one cannot touch the y-axis.
Oh.
That's how I know that the y-axis is now the asymptote. Okay. All done? Okay, what about this one? I'll give you a minute to try this one. So just look at the coordinates that you have. If it's on the x-axis, it will now be on the y-axis. If it's on the y-axis, it will now be on the x-axis. This is how we're going to see the homework this week.
Of course.
Okay, I'm glad to see that that is going to change. Where there's hope, there's life.
So I'm very confused now.
Okay. Don't be. Okay, here's minus 6 on the x-axis. So now we have to go with minus 6 on the y-axis. So here. Minus y, there's that minus 6 to 4, no, yeah, no, sorry. I just have to move it up. Let me just go with minus 6 is here.
It's the opposite, like with the x,
So on the x-axis, the x was minus 6.
now the y becomes minus 6.
Now the y is minus 6.
I understand that.
Okay, so now this is minus 1. So minus 1. This was minus 4 on the y. It will now be minus 4 on the x.
Oh.
So what will the graph look like? Well, something like this. I'm going to try and draw it here. So if you look at this now, apart from the fact that you might think it's a heart of some sort, you see the heart.
Oh, like that, yeah.
Now you see, I'm a romantic, they clearly not.
No, not.
Check here. They cut each other on the axis of symmetry. I know my graph is slightly off here, but they're cutting each other there as well. So we really, x becomes y, y becomes x. So if you look at the coordinates, Andrea, this was minus 6, 0. Now it's 0, minus 6. This was minus 1, 0. It's now 0, minus 1.
I understand now.
Or the x is minus 6, the y is minus 6. The x is minus 1, the y is minus 1. And can you see that this line helps you to indicate whether you've drawn this correctly or not? Good. Can we go to the next one? This one is a semicircle. So it used to be part of the part of functions in the old syllabus. Now it's part of coordinate geometry or analytical geometry.
How are we going to form a circle?
You're going to do circles in coordinate geometry. Yes.
Yeah, but I mean, yeah.
Are you going to have a full circle?
I'm scared.
No. X becomes y, y becomes x.
Yeah.
So you're going to still have a semicircle.
Why do you think? Am I doing it on the wrong place?
No.
No, it's probably. Oh, it's me. Oops. Oh, that's
Some people are confused.
So the way we're supposed to do it then.
No, you're right. It was just
No,
me.
she's trying to do it here on top, where
Yeah.
you're supposed to.
Do a different one. Yeah. That's why I've been drawing the other.
So those stuff will be like,
Yes, yes, like
but
that.
I'm confused now, so I'm not sure.
Okay, let's just go with this. -5 on the x-axis becomes -5 on the y-axis. -5 on the y-axis becomes -5 on the x-axis. 5 on the x-axis becomes 5 on the y-axis. And then I have to connect these dots. I'm just going to use a thicker pen so that it goes over that one. So that is what your graph should look like. And then, did you get that? Now, girls, just check this one. Check here.
Oh, you can actually say girls. It's just like, oh, but you can.
I'm used to,
Never
I used to say
mind.
that anyhow. Many years.
Never mind.
But I'm allowed now because it's not, we're not, there are no gender neutrals here as far as I know. We're only female, so that's fine. Can you see that if you use that line and you didn't know anything about swapping x and y, you can just say, well, that point reflects there, this point reflects there, and that one reflects there. So it's just this part that is the graph now. Cool. And are you getting this?
Yes, I understand.
Cool. Here's the last one. I think I should just move mine a little bit so that the scale is better. Jesse, how far are you with the compound angles?
So I just started doing numbers today, so.
You're still doing some grade 11 revision.
Yeah.
I'm going to give you a proper, I think my notes is about 20 pages. Yeah, but everything is there that you need. Yeah, I have more than enough examples. Now we have to revise a bit as well. Okay, let's go to drawing this. Andrea, would you like to give it a go? Okay, just tell me, just check the values.
You see, oh, don't come at
Okay,
me.
this -2 on the x-axis is going to be the -2 on the y-axis, so we have to look at that point.
Oh, I plotted it wrong.
And the -1 on the y-axis is the -1 on the x-axis. And now I just connect those two. Oh, let me just use a solid line for that.
Yeah, but I just plotted it wrong. I didn't write it. I just
I'm not
plotted it
fighting.
wrong.
Who's judging now, Jesse?
Nobody's.
Are you sure?
I'm just checking.
Cool. And you see that there they intersect on that line. So if one of your graphs is cutting the line y equals to x, the other graph will cut it as well. Because it's y equals to x. That point is the same for both. Okay, so that concludes what you need to know about inverses and their functions.
So isn't it? That's literally all we actually know.
Yes.
All the clown.
That's all you need to know.
Then why did I hate it this much last
Yeah, but the functions in grade 11 is extremely intimidating. Oh, you mean like you are?
Yeah, I hated it last there.
Yeah, she had an injury, so she couldn't finish all the subjects, so she's doing maths. That's why she said this, but I'm referring to grade 11. It was intimidating. That graphs are is
A lot
difficult.
of new information.
Absolutely. Okay, so I want you to do the following for me to be sent timelessly. On page, the pages are not numbered, sorry, exercise 6, number 1, 2, and 3. number 1, 2, and 3. I wanted to do number 3 in class, but unfortunately we ran out of time. And you will see there's another number 4 on the back there. Please do that as well. So it's just exercise 6, number 1 through.
And that
It
way
looks
you
like a lot
just
of
say it's
writing.
just exercise 6.
Basically. Yeah.
Okay.
It's like we just said everything.
So exercise 7, if you want to do it, or you can just refer back to me. I'm not going to give that to you as I will. So exercise 6, please.
But
Very check.
So the latest we can send out is Thursday, right?
no,
Wednesday,
Oh.
Wednesday, 11:59.
Wednesday.
23:59. That is midnight.
Oh no, I'm just taking.
And you can send it after hours. My phone goes onto silent from 9 o'clock.
And mine does that too.
Unless it's a serious thing, and you phone me like 10 times, then it will come through. Otherwise,
Just check this out to see if
because I know you guys have a different time schedule to what I have, and your parents have, so that's fine. So just send it to me before dawn
Yes,
on
Wednesday.